So if you have a more complicated equation, there might be some parentheses, extra numbers, and we have to simplify this enough before we can even do opposite operations. Most of the time, you immediately go to opposites. This time, on our left side, there's a lot going on that we could simplify and that we could combine. So what would you do first to simplify this? And it's really involving getting rid of these parentheses somehow. Good, you distribute. Perfect. And yep, instead of positive 5, we would want to distribute it to negative 5. So we multiply it. Most people don't write the 2 times 3x. They just say in their head, I'm multiplying 2 times 3x. That makes 6. And then you multiply the 2 times negative 5. And anything else that is not being affected right now is just going to come down. We still have plus 15. We still have 7x minus 4. Good. So now we still have a lot of stuff going on the left. We can combine some like terms. So what like terms could we combine together on? And exactly. When you're typing your responses, sometimes what I'm saying is exactly what you're typing. So negative 10 plus 15, that is correct. We add those together. You can do it in your head if you're comfortable with positives and negatives. So positive 5 is correct. Or if you have a calculator, use a calculator. They're great. So now we have variables on both sides. So do you know what opposite we do to get one variable over to combine with the other variable on the other side? Usually it's best to figure out what we're going to do with the variables first. Good. Subtract 6x from 7x. Now at this point, you could have also subtracted 7x from 6x. It actually doesn't matter. It'll change what happens after, but you could have done either. So 7 minus 6 is 1x, but when it's the number 1, we don't have to write it in front of the variable. Everything else just came down again. So now what's our last step? Add the 4 to the 5. Always pick that opposite operation. Opposite of subtraction is addition. Good. So let's take it up one more level. Yeah. Yeah. Sometimes when you're typing pretty fast, it's easy to make little slip-ups in the language, but I got what you meant by adding 4 to both sides. So what can make this even more complicated is to take an equation now that's not even linear anymore. All right, the last number first because it will make it easier to write a nice problem. Okay. So this is still an equation. Our goal is to still figure out what x is, but now because there's a 2 on it, it's a quadratic equation. This little 2 exponent makes it quadratic. So what ways could you solve a quadratic equation? It's actually a lot of different ways, but really we just need to remember one. What's even just one way to solve a quadratic? Okay, forgot, and that's fine. It's a lot of information to remember in math. So the first way is by graphing. You could graph to find the solution. The second way is by factoring. Yep. So now it's coming back. The third way is completing the square. This completing the square is good to know for certain situations, but it's actually kind of a poor way to solve a quadratic. It's not something you want to do very often, but you need to know it because it can be useful for circles or for rewriting parabolas. And the last way is quadratic formula. So which way do you want to see? We could do all four, we could focus just on one. Any of these would work to actually solve and get our answer for x. All of them, okay. So even if we do all four different ways, we're going to get the same answer every time. They're just strategies to get the correct answer for this. So the first one is graphing. To solve it by graphing, it does need to be equal to 0, which ours is. And you can graph it by hand, or it's usually when you're solving it by graphing, you use a graphing calculator. A lot of people have handheld like TI calculators. I also really, really like this online Desmos graphing calculator. It's very, very easy to use. So you basically just type it in. Yep. It's probably the best online graphing calculator I've seen, and it's free. So that's a big plus. So we have x squared plus the 7x plus the 12. And what we're looking for when we graph it, you'll see 3 dots already popped up. That's because they're important. They all mean different things. For what we're trying to do, where we're solving, we said we wanted to know where it equaled 0. So we want to know where it crosses the x-axis, because where it crosses the x-axis, y is 0. And on this one, it's great because you can just click on the point and it pops up, or you can read the graph and say, well, every 2 lines is 1 space. So that's at -3, that's at -4. If you have like a handheld calculator, that process is different for every calculator, so it's hard to describe. So by graphing, it's by far the easiest because you just literally look at it and say, those are our answers. Most of the time, it would probably write it as x equals -3 or x equals -4 for the answers. For factoring, factoring is backwards. Yeah, graphing is a really, really quick one. It's, you type it in, click on the dots, you're done. Factoring, I did set this one up nicely for factoring, so it's actually not going to be that long of a process either, but we do have to remember it. When we factor, we're trying to get this quadratic back into 2 parentheses. It's basically doing the backwards FOIL process. When you FOIL something out, you have 2 parentheses and you had to do first times first, outer times outer, inner times inner, all of that stuff. Well, factoring is doing that process backwards. So when it's only x squared, there's no coefficient in front. The factoring process is pretty easy. We take the x squared, and that's the first part of each parenthesis. So then the next part depends on these 2 numbers. We have to find 2 numbers that multiply to be the 12 and add to be the 7. It's always equal to the last number before the equal sign. Yep, it comes back. If you haven't seen it for a while, once you start hearing about it again, it makes it a little easier. So it can be any 2 numbers as long as it fits that pattern. 2 numbers that multiply to be 12 and also add to be 7. So like 6 and 2 wouldn't work because 6 times 2 is 12, but 6 plus 2 is 8, and we want it to be 7. Good. +3 and +4. So we have +3, +4. And you'll see we're almost to our answers. We already know from graphing it's -3 and -4. So when you're solving, you do the factoring process, but then we have to use something called the zero product property, which basically means if your equation's equal to 0, and you have 2 things multiplying together, you can actually set each one equal to 0 by themselves. they can split up into two separate equations, and now that they're two separate equations, they're just normal equations to solve. We just do our normal opposites, but we just do one at a time. Yep. It's something you learn a lot in Algebra 1, and you probably see it again in Algebra 2. Most of the time, factoring is covered in both classes because it's pretty important in the overall math classes. So the first one, we would do subtracting 3. That's our first opposite. And then the second one, we would do the subtracting 4 from both sides. And when you're doing a lot of similar problems, some people just skip and they're like, oh, I know it's automatically going to become the opposite number. So that's factoring. Completing the square. And just go to a new page so we can have enough space. Completing the square is the only one that doesn't want to be equal to 0. Completing the square is a very long process. And like I said, it has its uses. It's probably the longest way to solve a quadratic. Sorry, my chat message did something weird. Okay. Yeah. Uh-oh. Yeah, I'm describing it so negatively. It's my least favorite way, but it has its uses. It needs to be known, even if it's not the best way to solve. So our first step is to get the numbers with no variables to the other side. So we move it over using those opposites, and I'm going to leave a blank space there because we are going to figure out a number to add here, and that number we specifically want to make this a quadratic that factors in a certain way. We're not just doing it at random. We want to pick a number so that when we factor, we get two that are exactly the same. Yeah, it's a weird process because you're adding in something just out of nowhere. Like most of the time you say, oh, here's this number, I need to do the opposite of it. Here we say, I have to add this in. So to figure out that specific number, you take the middle term, the 7, you divide it by 2, and then you square it. I figured out this actual kind of formula or pattern by studying a lot of problems where they had two parentheses that were the same and they FOILed them out. And once they saw that pattern, they're like, well, how can I do this backwards? And they figured out if I always take that middle term, divide it by 2 and square it, that's going to give me the correct number to add to both sides. So this time we are going to get a decimal. So the Desmos Calculator can actually do regular calculations as well. If you don't type any variables, we can just type in the 7 divided by 2. Gives us the 3.5, because we had to do what was inside the parentheses first. And then we square that number, 3.5 squared. So 12.25 is the number that we add to both sides. Some classes make you leave it as a fraction so that you're not working with any decimals. As long as it comes out to a decimal that's nice to work with, I think it's easier to just use the decimals. So we had originally gotten 3.5. We squared it and got 12.25. And that helped us figure out what to add to both sides. And on the right side, that we can just combine together. There's nothing weird about that side. We just say, well, what is negative 12 plus 12.25? So what do we get when we add negative 12 plus 12.25? And it's a little bit harder since it's a decimal. So I'll head over to the calculator again. So that gives us, oh, okay. Sorry about that. I don't really know what happened. Nothing was glitching on my side. But what I had asked was, what's the negative 12 plus 12.25, which is 0.25. Yeah, sometimes if your connection is poor, it can make it a little glitchy here and there. So we combined that right side. On the left side, we need to factor again. Normally, when it's not a decimal, we go through that whole process again of figuring out, well, what multiplies to be 12.25 and adds to be 7. But the cool thing about this process is we actually already have the correct number. The process we did up here, this kind of work to the side, gave us a number and a middle step, that 3.5, and that actually is the correct number. 3.5 times 3.5 gives you the 12.25, and 3.5 plus 3.5 gives you 7. So that is one cool thing about this process, is that part of what you need was already done when you were trying to get somewhere else. So this would factor to be x plus 3.5 times x plus 3.5. Now, on our last problem with factoring, we did zero product property and split it up. That only works if you're equal to 0. We're equal to a number here. So our whole purpose in doing this is that now that they're the same, you can write two things that are the same as one thing squared. So we rewrite this as that one parenthesis squared. And the purpose of doing that is, again, to get from two different x's down to just one. We always, with these problems where you have multiple x's in the problem, you've got to break it down so it's just one variable so that we can actually solve. So now we do opposites again. What's the opposite of squaring something? For addition, we subtracted. For multiplication, we divided. What's the opposite of raising something to the second power? You may have typed something that didn't show up. You said, I think, and then it's just blank on my side. Oh, okay, okay. That's fine. If you're just thinking, take all the time you need, but I thought it was glitching again. You know, addition and subtraction are opposites. Multiplication and division are opposites. And this one is used less often, so it's not as easy to remember. But squaring something, the opposite is to square root it. It's used a lot less often than our regular opposites, so it's harder to remember this opposite. Yep, because squared is a special kind of multiplication. 5 times 5 is 25. And square rooting is a special kind of division, basically. You're searching for two numbers that if you divided by one number, it would give you the exact same number as an answer. 25 divided by 5 is 5. So they're very specific opposites. And we just had another student join. Thanks for joining, Denise. Right now we are solving a quadratic using completing the square. It's something you might see in Algebra 1 or Algebra 2. So we're almost done with the process, but where we're at right now is we are taking this squared and doing the opposite, which is to square root. Now, square root is a little bit weird. When you square root a number, it actually has two answers. When you first started using square root, it was always assumed to do positive. But now when we're square rooting, we're going to actually have two possibilities, positive or negative. 25 divided by 5 gave the same number 5, but 25 divided by negative 5 also comes out the same number, negative 5. So when we square root 0.25, we have a positive answer and a negative answer. And we had one more student join. Thanks for being here. I don't see sound right now. If you can't hear, I'll type a message. Oh, nope, now it's sound. Okay. So thanks for joining, Ricky. We're almost done with this particular problem where we are solving by completing the square. So now square root of 0.25 is 0.5. But we just have our two versions, positive and negative. So when we have our two different versions, just like when we factored and we had to split it into two equations, we do that again. This time we have our positive answer and our negative answer. So now we do opposite operations again. So when we solve an equation, x plus 3.5 equals 0.5, what opposite would we do to get rid of the 3.5 and move it to the other side? If you want to answer, you can type it into the chat box, or you can unmute yourself and answer. And we got an answer in the chat box. You're correct. We want to subtract. Be minus 3.5 from both sides. I'm running out of room, so I'm going to squeeze the answer in here. 0.5 minus 3.5. I'm going to get rid of all my other stuff. Gives us negative 3, which is the answer we already knew was coming. We've solved this by graphing, we've solved this by factoring, and now when we solve it by completing the square, same answer. They're all different methods to get the same thing. On the second equation, we actually do the same opposite. We still minus 3.5. What's different is this was a negative 0.5. So when you do negative 0.5 minus 3.5, it gives you a different answer. This time it gives you negative 4. So we can also solve this by quadratic formula. Denise, if you have a particular topic from whatever class you're in, you are welcome to ask for, sorry, my brain stopped working there for a sentence. Yeah, completing the square is a lot longer than any of the other processes. So Denise, if you have a particular topic you want to cover, feel free to type it into the chat box and we can cover it next. We're going to cover this last one of quadratic formula. So quadratic formula, they actually got by completing the square, but with only letters. Instead of writing numbers in front, they said ax squared plus bx plus c equals 0. They went through, I'm not going to show that because it's super long as well, but they went through, they completed the square, and they figured out at the end this fairly long formula as well. Negative b plus or minus square root of b squared minus 4ac all over 2a. So this is definitely not as long as completing the square, but it's still kind of time consuming. If you can factor or if you can graph, those are two really great options. If you have a weird question that's not going to factor, then quadratic formula is a good option. So what each of these letters mean are the numbers in front of the variables. And then if there's a number at the end behind the variables, that is our c. So here we have in front of x squared would be a, which right now is blank. We'll talk about that in a second. In front of the x is 7, so that is our b. And then behind the x is the 12, so that's our c. And this did need to be equal to 0, but it already was. So this very first one doesn't have a number written in front. What number do we know is there, even if it's not written in at first? And we got a chat answer, which is correct. A is 1. If there's no number already written, then we know that we can put a 1 there. So once you've identified all of those, we go to our quadratic formula and plug them in. So we have negative b, negative, and then the b they said was 7 from our problem, plus or minus square root of b squared. We're using the 7 again. Sometimes they get used more than once. Minus 4 times a times c. A is 1 and c is 12. All over 2a. So now how do we simplify this? So each kind of separate grouping, we're going to simplify separately at first. The negative 7 right now, there's nothing to simplify, so we're going to leave that negative 7. The square root of 7 squared minus 4 times 1 times 12. You could do a lot of that by hand, but I'm very much a pro calculator person. I love calculators. So on this particular calculator, you can actually type in the entire thing. We start with the square root button, which kind of looks like a check mark. And then it was 7 squared. This a squared button brings up the little 2. Minus 4 times 1 times 12. So you type all of that in, and it just pops out the answer in the lower right-hand corner. So all of that goes down to just be a 1, which makes this look a lot nicer, because now we don't have all of that going on. And then on the bottom, that one we can do without a calculator. What do we get when we do 2 times 1? Anytime we have a number multiplied by 1 or a letter multiplied by 1, it's just that number itself. 2 times 1 is just gonna, I did, so maybe it glitched again, sorry. I had asked what do we get when we do the 2 times 1 because we didn't really need a calculator for that one. So we get to this point again where it's not quite our answer. We know we're going to get a negative 3. We know we're going to get a negative 4. But we have this plus or minus symbol. No problem. Computers are glitchy. So the plus or minus symbol is similar to what we saw in completing the square. It actually literally means 2 options. We're going to have to split this up again. This has happened 3 times with our processes. Factoring we had to split up at some point. Solving with completing the square and quadratic formula. All of them had to be split up. Yep, negative 7 though. That minus sign does stay with it. because the formula said it was a negative b. And so that 7 became negative when we plugged it in. So when you simplify fractions, yep, so negative 7 plus 1 over 2 and negative 7 minus 1 over 2. And when we simplify these fractions, you do the top, or if there's something to do on the bottom, we do the bottom first before worrying about any division. So we simplify and do the addition on the top first for both of them. So what do we get for the first fraction if we simplify that down now? Again, be careful with your negative signs. You said positive 6 over 2, but a negative plus a positive 1 will come out negative if the bigger number was negative. And now we can do the division, which gives us that first answer of negative 3. Still came out with the same answers. Now, positive and negatives are really, really important, but they're easy to overlook. It happens all the time, even with people who have been doing math for a very long time. So our first answer is the negative 3. How about the second one? What are we going to get for our second fraction? If we do the negative 7 minus 1 over 2, what are we going to get next? Good. Negative 8 over 2. And then we do our division again and get our answer of negative 4. So we are pretty much out of time. Yep, same answers for all of them. That is pretty cool that there's so many different ways to solve. So we're out of time. I know one of you don't actually have math right now, but if you do have to do some math classes and do end up needing some help, I also do individual tutoring sessions where it's just me and you and not a whole group. So you can contact me at april.barton@graduationalliance.com. If you're actually in one of my classes, you can send me chat messages, or you can text me at 801-214-8782. Thanks for showing up today and participating so much. It was fun to talk about math. It's obviously one of my favorite things. We will be having another session again next week at the same time, and hopefully I'll see you guys again. Have a great day. Bye. Thanks.